Okay, the challenge it comes. Give us. Let me. Oh, this one. Okay, let me put it again. 30 seconds, guys. Be ready. 30 seconds. Your pencil's ready. Your name is on the packet. 30 seconds. This is what we're going to do. You're going to add the numbers from 1 to 20 in 30 seconds. 1 to 20. I'm giving you just 30 seconds to do this. Right. 20. There's a challenge. You can join quick. We're adding numbers from 1 to 20 in 30 seconds. How many people got it? You fell? Okay, that's fine, that's fine. You fell? You didn't do it? Okay, that's fine. Okay, guys, now a question. Is it possible? Is something possible? Did I give you something impossible to do? Or is it something that maybe you could do later? What do you think about that? I feel like this is doable. You feel it is doable. That's a good thing to say. What about you guys? You think it's doable? We can do it. Maybe you don't know yet how to do it, right? So let's see if we can discover how to do this. It's a big challenge, right? To add 1 to 20 in 30 seconds. So if we can do that, that's gonna be very great. So let's see if we can do something similar to this. So let's talk about history first. I'm not an history teacher, but let's talk about history. A guy named Carl Friedrich Gauss, that's the name, maybe I say it wrong. So when he was 9 years old, 9 years old only, his teacher, that's not him, that's the teacher, but that's not a real teacher. His teacher was busy one day, he needed to do something. So what he did to his students, he gave them something to do while he could do his own work, right? So he gave to the class to add numbers from 1 to 100. So he thought that would take the whole period, right? For the students to add, 9 years old student to add 1 to 100. So in a few seconds, Gauss was done. A few seconds, less than 30, thank you. Gauss was done. So the teacher was surprised. How did this guy, this little kid, did this in a few seconds, maybe 10 or 15 seconds? He was done adding 1 to 100. So what did he realize? He realized something, that if you have numbers from 1 to 100, I'm not gonna write everything, but be with me. Like, let me just keep a few, going to maybe 97 here, 98 here, 99, and then 100, right? So he realized, be with me, everybody, that when he add 1 to 100, what does that give you? 101. 2 to 99, what does that give you? 101. Exactly. 3 to 98, what do you get? 100. So same thing again. So if you keep going, you will always get pairs of 101. So if we have how many numbers they need to add 1 to 100, how many numbers are there? 100 numbers, right? So if you have pairs, if you make them in pairs now, how many pairs do you have? You have 50 pairs, right? 100 numbers to add together. You arrange them in pairs, so you have 50 pairs. So you realize if each pair is 101, so what could he do? Multiply 50 times 101. So that's what he did. It took him like 10 seconds. He realized, oh, this is the same thing. Maybe this is 2 seconds, right? Same thing. So let me multiply. I'm gonna get 50 pairs. Let me multiply 50 by 101. So this is maybe 4 seconds, and then he multiplied it. 10 seconds, you get the number. So what was the number? I think I have it here is 5,050.
Now I got a question.
Yes, question.
Would this method work with an odd number?
That's a good question. Will it work? We will try it. That's a very, very good question. Because from 1 to 100, that's a how do you call that? Even number. So will it work for odd numbers? That's a good question. We'll try it. All right? But before we try that, let me try you again. Do you want to try the challenge again? 30 seconds to add 1 to 20. 30 seconds to add 1 to 20. You ready? Ready, ready, ready. You're gonna follow this model and then see if you can get it. You don't have one yet? Go. Get a pencil, be ready, 30 seconds. Ready, set, go. Anyone did it? How much you get? 10. Did you get it? So it was possible. Congratulations, guys. You did it. You did it. Good job. You didn't do it? Did you do it? So once we find the first pair, we don't even have to continue to go, right? We find the first pair, add in 1, 2, 1 up 2, 3, etc. And then if we skip, we go 19, 20. 1 plus 20 is 21. We don't need to continue. Maybe if we're still skeptical, we want to try 2 plus 19 is still 21. So everything will be 21. So if I have 20 numbers, how many pairs do I have? 10 pairs, right? 10 pairs. 10 pairs of 21. 10 times 21 is, as you said, 210. So that doesn't take 30 seconds, right? Sure. Now, how do we call that? Adding the terms of a sequence. How do we call that? When we add the terms of a sequence, do we know how we call that? Arithmetic sequence or geometric sequence, it doesn't matter. Once we add the terms, how do we call that? There is a word for that. We used it last time, and I said, let's hold on to it, we'll come back to it. Just adding the terms, like adding 1 plus 2 plus 3 plus 8 until 20 or 100. How do we call that? Do we know? No? We forget? We know the word because we used it last time, but we're not sure what does it mean. Common difference? The common difference is something else, no? What's the common difference? Since you say common difference, what's the common difference, guys? What is the common difference?
The number that is added or subtracted
to get the next term. All right, so that's what we're doing. I'm adding them by 1 here, just 1. 1 plus 1, 2 plus 1, 3 plus 1. So the common difference here, what's the common difference here? Come on. 1. All right, so we're not talking about common difference, we're talking about something else. And it is called series. You remember we said the word last time, right? People said series, but I said hold on to it. We're gonna come back to it. So series is exactly what we're going to do. It is adding the terms of a sequence. All right, when we add the terms of a sequence, we're doing a series. Okay, so I think you should write down this definition, right? What is series? Add the definition. Write the definition, please. I'm gonna give you a vocabulary, but I need you to write the definitions in your own words first, and then I'll give you the vocabulary. So how would you call a series? Let me see your words. What word would you use? Show me the definition of series. Write it down. You write it down in your own words. I said like, if these, let me give you the example again. If 1, 2, 3, 4 are the terms of a series, and then when I add them together, 1 plus 2 plus 3 plus 4, when I add them together, I have a series. So what is a series? Huh? How do you define it? Adding terms of a sequence. Someone said adding terms of a sequence. What did you say? I don't see it. What did you say for series? All we can say is the sum of the terms in a sequence, right? The sum. Sum is, when you say sum, you're talking about adding. So it's the sum of the terms, sum of the terms in a sequence. All right. So now we're going to talk about arithmetic series first. All right, arithmetic series formula. So what is the formula? We don't need to like every time. We don't need to try to figure it out. We need to find a formula for arithmetic series. So instead of me giving you the formula, like we did the last time, we're going to derive the formula together. Okay? So we're gonna follow what Ghost did and then derive the formula together. The first thing we're going to do is in your paper. What is the first thing? Can somebody tell me what is the first thing we're going to do?
Deduction and formula. Deduction and formula.
Say it louder.
Deduction and formula.
Yes, that's what we're going to do, but the steps. You have the steps. Step 1, what are we going to do?
Write it forward.
We're gonna write it forward. All right? We're gonna write it forward. So in your paper, you surely have something similar to this. A1 plus A1. I'm gonna put parentheses here because I have another addition here. You have this, right? In your paper. All right, so if you have this, now what does it mean? What each of these mean? What is A1?
First term.
The first term. What is A1 plus n minus 1 times d?
The first term plus the term that you're looking for times the complement.
So how would we call that exactly? That's the first term, and this is the, what comes after first?
Second.
That's the second term. If I had to write the third term, it would be A1 plus N minus 1 times 2D, because D becomes 2 times now, etc. We would continue to do this, but we can skip them and then go straight to AN, which is the last one. So that's writing it forward. Now the second step, what we're going to do, write it. It's on your paper. Second step, backward. If you see, guys, read it for me, please. So if we do that, we're gonna start with what? What term we're gonna start with? A-N. Oh, let's read it like this. Let's read A sub n, right? A sub 1, A sub 2, A sub 3, A sub n. So A sub n, that's S sub n. So A sub n, why we start with A sub n? That's the last term. A sub n is the last term. Thank you. A sub n is the last term. If we writing it backward, so we're gonna start with A sub n. And then, what's gonna be the next one? A sub n. When we were writing it this way, we were adding. But if we're writing it backward, what should we do? We should subtract, right, from the last. Thank you so much for that. So we will do the same thing until we go to, what would be the last one now? A sub 1, the first one, because we write it in backward, right? So first we write it forward, second we write it backward, and then third, what do we do? It's on your paper. We're gonna add them vertically. Okay, so let's do this. So S sub n plus S sub n, what is that? Two something to S sub n. Okay, now when we add these two, what do we get? A sub 1 plus A sub n, right? When we add these two, what we're gonna have? If I'm adding these two, I'm going to get what? A sub 1 plus A sub n. And when I'm adding these two, what's gonna happen?
The n minus 1 cancels out, so plus 2d.
So both of them cancel because they are just one term together. Just one term. So what's gonna happen if I keep adding? If I keep adding, what's gonna happen?
You're just gonna keep ending up with a sub 1 and a sub n.
I'm gonna keep having, thank you, I'm having just one student participating, guys.
Wait, why did y'all cancel that thing out again? And
Because this one is positive, this one is negative, that's why they cancel each other. And every time I'm gonna find the same thing. A sub 1 will be added to A sub n, and this one is positive, the other one will be negative. Now, another question would be, why do we have a subtraction here, and then we have an addition here?
and the
Exactly.
going forward.
Exactly. So we were adding going this way, and if we go the other way, we need to subtract. So every time we're going to have the same thing. So if we're going to have the same thing, so how can we condense this, make it smaller? 2s sub n.
Add like terms?
They are the same thing, right? How do we add them? Like a sub 1 plus A sub n plus A sub 1 plus A sub n. What does that going to give us? If we have to have it only just 3 times, let's say just 3 times. If we have to have it just 3 times, what is that going to be?
Oh, we're supposed to add?
Let's just say that we have it only 3 times, right? So if we have it just 3 times, how would we condense this?
A of 3.
A sub 3, you mean?
A sub 3, yeah.
A sub 3 plus
A sub 3n.
A sub 3n. Okay, that's one idea. So let me hear somebody else. This side. I hear from this side a lot, not this one. Go ahead, guys. If I only had that, A sub 1 plus A sub n 3 times, so how could I condense this together?
I'd put it like square. Would I put like square or something?
Square? Alright, let's check this out. So when we add things like A plus A plus A, how can we condense this? It becomes square something? A cube? Everybody agrees with that? No? So what do we do? It will be 3A? How many people agree with 3A? Show me your thumbs up if it's 3A. 3A or is A cube? Show me. I only see one. Joyce, you with us? We're gonna choose between 3A or A cube for this. If I'm adding A plus A, is that 3A or A cube?
Yeah.
3A? Which one? 3A on the side. So what do you think, Chase? You're gonna keep 3A, we're gonna keep a cube, or you're gonna change it? You wanna change it to 3A? You know why? Alright. So when do we get A cube in this case? Thank you so much. I really appreciate that. Thank you, Chase. So if we multiply A 3 times, it gives us A cube, right? So it's a good difference that we need to do. It's not too late to do this, but it is good to do, right? So in this case, let's come back to this. So what should we do here?
It will be, I think we will end up with 3A sub 1 and 3A sub.
Okay. Or we could just have 3A sub 1 plus A sub n. How many do we see? 1, 2, 3, right? This would be 3A sub 1 plus A sub n. Do we agree with this? Now, I said if it's 3, but if it's not 3, if it's more than 3, we don't know the number. So that number we will replace it with n, right? N. N is a number that we don't know yet, right? Could be 10, it could be 100, it could be 100, so it's going to be n. So now, we need to solve for S sub n. So if I'm solving for S sub n, what is the formula going to be? S sub n. It's going to be n divided by 2, or n times A sub 1 plus A sub n, everything divided by 2. So this is the formula that goes this covered, and it was able to do everything. You take the first term, you add it to the last term, you multiply by the number, divided by 2. So let's try his work again. So he had to add how many numbers? 100 numbers, right? Multiply the first term, 1 plus last term, 100, divided by 2. First term plus last term is 101 times 100 divided by 2, or times 50, right? 100 divided by 2 is 50. Yeah, 50 of that. So it's the same thing. Same thing we did also. We had 20 terms. Add. So when we divide 20 by 2, we have 10. 10 times 21 is 2 to 10. So that's the formula. Now your question, if we have to add if we have to add numbers, like 1 through 5.
Wait, I feel like for
Uh-huh.
an odd number, it would be a remainder that we would need to add on the side.
Alright, let's 1 plus 2 plus 3 plus 4 plus 5. So we're gonna do what? 1 plus 5 is 6. 2 plus 4 is 6. Plus what?
3.
Plus 3. What's the answer? What's that? It's 15. So can we do it here? How many numbers? 5 numbers, right? 5 times 1 plus what? What's the last one?
5.
5 divided by 2. So 1 plus 5. 6. 5 times 6. 30 divided by 2. 15. So it's still
Oh.
Maya. Good. Does it still work? So now, why I didn't give you the formula and just tell you to use it? Why didn't do that? What do you think?
Because these are brain.
So yes, and by using your brain now, do you need to study that formula? Do you need to study it? You still need to study it, but not as much as if I just came and gave you the formula and said apply it, right? But if you know how to get it, it becomes easier for you. We put it forward, backward, we add them up, right? And then we came up with that formula. So this is the formula that we're going to use then for the arithmetic series. Alright, I need that formula to be on your paper like a big thing. Oh, it's okay. Do we have the formula down? Written down? See? You're confused on this? Or you have a question, help me with the question. If you ask me a question. So first, did you see us making the pairs? So you understand the pairs, right? Now, how many numbers do we have? I need to know how many numbers from 1 to 20, how many numbers? 20. So if I have 20 numbers, I pair them. So how many pairs do I have?
Yeah, I'm just writing down what you put on the board.
It's
How
like
many
I
pairs?
understand it.
Where's that
Pair
for?
them.
I see it for you.
Let's say that we have 20 numbers and we put them 2 by 2,
Without my consent.
right? So how many 2s?
Mr.
So,
Oh, no, I came and looked as well.
so I just put
Something
by
about
2
some 9-year-old.
divide by pair.
Oh, yeah.
Because I have 10 pairs
Keep out of
and each
these,
pair is 21. And 10 pairs of 21 is the
We're learning arithmetic series.
no, the pairs. We don't know what the pairs are going to be. We just have to add them. The first one with the last one. Right? The second one may follow the last one. Add them. So we get the pairs, whatever the numbers they are. Right? First numbers. Right? And then I know how many numbers. So I divide that by 2, multiply it with, that's the same thing we have. First, 1 second, sorry. First plus last, right? How many numbers we had? Divided by 2. Yes.
I'm confused. Should I just-
I know. We did a big challenge somewhere. We added numbers from 1 to 20 in less than 30 seconds.
Okay.
You don't believe that, right?
No, can you tell me?
As
Devon,
Javon, did you do it,
I'm
Javon?
doing my notes.
I have a question.
Yes.
So, where is there, like,
You were set for them.
Equation like this, like, actually this one,
Yes.
and we use N is you gotta write both of them together.
Yeah,
Like-
they kinda go together. So it's comfortable. I'll print out this comfortable.
Like, what do you something like that?
We're gonna do it. Let's do it. We have a guided practice, yes.
Okay, you keep saying the formulas combined, do I have to write both of them together?
The formula is this,
This.
yes, S sub n, right? So, we have a guided practice, meaning we will do it together. I'll do it with you, or I'll do it with you before we continue. Anybody did it on their own to guided practice? You did it back? No? Ladies in the back. Did you do the guided practice?
There's ladies in the back.
Alright, let's do it together.
What did y'all put down?
There should be,
It's on you.
yes, yes, go ahead. I'm not sure what they did with my pass.
Wait, that's something.
Someone left this book for me, so use it as a pass. Do it, do it. Alright, waiting for you, huh? Yes, guided practice, it says, we need to find the sum of the series, right? The sum of the first 50 multiples of 7. The first 50 multiples of 7. We can do that under 30 seconds, right?
No.
Yes. The first 50 multiples of 7. If they are multiples of 7, so what's the first one is going to be? What is a sub 1?
That would be.
7, right? Multiples of 7. 7 is a multiple of 7, right? The first one will be 7. So the common difference will be 7 because we will keep adding 7 every time. We are here. You with me?
Yeah.
We'll keep adding 7 every time. And then we need to add, how many do we need to add? 50. 50 together, right? So
We're adding 750 times.
we're adding not 750 times, we're adding 7 plus 14 plus 21 plus 28.
To get 50.
No, until we get 50 numbers. That's 1, 2, 3, 4, right? 28 is the fourth term. So we need 50 terms,
Oh.
right? 50 terms, and all of them, they need to be multiples of 7. That's what we do. So now, we have these informations, they are very important, but we're missing one information so far. One information. What do we have in the formula? Let's go back to the formula. That's the
Have the
first
first
term,
term.
and then that's what? What is this term?
The biggest term? No, the final term?
Last, yeah,
Okay.
final or last. First term and last term.
Okay.
So, do we have the last term?
No.
No. So that's what we need to find. Once we find the last term, everything is
I thought that
becomes.
term was trying to find. Is it as for a last term? Because cutting numbers going from.
Alright, to find the last term,
They give you, amount of number to find for the last
Oh.
one.
a sub 50, we're gonna use the formula we know before from previous class. A sub n, we know is A1, what else plus n minus 1, D, right? That's A sub n. So we're gonna do that.
So we can
So-
minus.
So what is A sub 1 is 7 plus, what is n minus 1?
49.
49. Is 49 times what? 7. So what is this number? A sub 50. What is this number? Give me this number, guys. You can do it. Alright. Alright, let's do the multiplication first, right? Multiplication first. 49 times 7.
When are you gonna get
Plus, I'm not sure. Do you have
Oh,
any?
let's
Do
go.
you have any at home?
350? No. 350.
So 350, right? You do the multiplication first, then you do the addition, right? 350. So we have 350 as the last term. Now let's go back to the new formula that we just derived. Using the new formula, let me use black. So what is S sub 50? S sub 50 is going to be, what is N? 50. We have it there, right? The first term is, the last term is divided by 2.
Okay, wait, I get it now. I'm slowly getting it.
So we're gonna add this, multiply, divide, etc. We're gonna do parentheses this time, right? If you have parentheses, you do it first. 357 times 50 divided by 2. Or times 25, right? So we're gonna do 3 plus 357, you said? Times 25, right? 50 divided by 2. 50 divided by 2 is 25.
Okay, so we,
The 25
wait.
years.
okay, so we do the parentheses first and we divide the n by the,
You can do it any way. You can do the parentheses, multiply by 50 divided by 2.
oh, okay.
Or you
It's all gonna
You
be
do.
the same. right?
Yeah, you do the parentheses, multiply by 50 divided by 2. And 50 divided by 2 is 25. This is what we get, 8,925.
Bro, I need my computer, bro. This is a big boy math, bro.
Alright guys, I need you to put,
I'm gonna just start bringing my.
you see I left a part of it blank. I need you to complete this. Boy, complete the blank for me. What do we have here?
My calculator is in my phone, so I need to start bringing my phone to class.
Wait, why did we multiply by 25?
Why we multiply by 25? You want?
50 by 2.
I got it. You good? You sleepy today, huh?
Wait, Mr. Chandra, you should start making a list of stuff you need for the classroom, because that's what Mr. O is doing.
Yeah, for the computers,
It's mainly the computer
Um,
we need, bro.
do you have computers at home? That's the first thing I need to know.
No,
Oh.
it's the other kids.